So the first thing we did was we just simplified. It says simplify and state excluded values. So the first step here is just to factor everything. I'm going to factor my numerator and my denominator. And then I'm going to see if anything causes an issue. So I look first to see if there's a common denominator. Is there something in common in that numerator between all three of your terms? 3, and for the variable you would use p. And then you're going to divide that out. So this is going to be 3p cubed divided by 3p is just p squared. Here we'll get 7p, and here we'll get 12. In the denominator, I can also take out that 3p, and I'm left with p squared plus 12p. All right. Before I do anything, I need to make sure I factored completely, which I have not. So I am going to continue to factor here. I'm going to look at that 12 and say factors of 12 that add up to 7. So this is going to be factoring to p plus 4 and p plus 3. All right. In the denominator, factors of 27 that add up to 12, that's going to be p plus 9 and p plus 3. And so this is completely factored. Before I cancel, I will determine my excluded values, okay? To do that, I'm going to take every single factor in the denominator and set it equal to 0. So I'm going to take the 3p and I'm going to set it equal to 0. I'm going to take the p plus 9 and set it equal to 0. And I am going to take the p plus 3 and set it equal to 0. All right. And so when I do that, I can then see what my excluded value should be. Based on this first one, if I solve for p, divide both sides by 3, that's going to leave p equals 0. Here, if I subtract 9, that's going to be p equals -9. And if I subtract 3, that's going to give me p equals -3. These are my excluded values. Okay, those are my excluded values. The second part of this is simplifying it. So once I have done my excluded values for my denominator, now I'm going to cancel anything that is the same. So this 3p and the 3p can cancel. Those are identical. Okay, the p plus 3 and the p plus 3 can cancel. Those are also identical. So in the numerator, I'm left with p plus 4, and in the denominator, I'm left with p plus 9. That is my simplified version of that. So this is the simplified piece, and this is the excluded value piece. So multiplying and dividing are basically the same. You're going to keep change flip if it's divide. But basically from there, you're factoring everything and you are simplifying it, right? So I'm actually going to start with 16 because that's multiplication, and then we'll do the other one because that's division. So for multiplication, I can go straight to my factoring. So here I'm going to say factors of 18 that add up to 11. Well, that's going to be 9 and 2. So I'm going to say v plus 9, v plus 2. In the denominator, all I can really do is take out an 8. So I'm going to take that 8 out, that common denominator, that common factor, and I'll have v plus 9. You put your multiplication here. In the numerator of my second one, I can take out a 3, and I'm left with v plus 10. And in the denominator, I really can't do anything else. All right, so that denominator is as simple as it gets. And now I'm going to cancel with multiplication, not addition and subtraction, but with multiplication, you can cancel any top to any bottom. That means directly on top of each other or diagonally, okay? So I just go through each piece of it and decide if it can cancel with something. So I'm going to look at this v plus 9, and I can see that it will cancel with this v plus 9. Then I look at the v plus 2. That will cancel with this v plus 2. This 8, there is nothing I can cancel with that 8. So I typically do something like that, put a box around it so that I don't miss it when I go to the very end, right? I look at the 3. Nothing can cancel with the 3. Nothing can cancel with the v plus 10. So in my numerator, I'm left with 3v plus 10. And in the denominator, I am left with just an 8. And I am done. That is my answer. I cannot reduce the 10 and the 8 because the 10 is part of a group. All right? So I can't reduce those. If that 3 had been a 4, I could reduce the 4 and the 8. They're both outside of a group, right? But nothing will reduce here. So this is my final answer. And I do not require excluded values on these. I've already seen that you know how to do it on the first page, so I don't need to see it again. But sometimes things will ask for excluded values even for multiplication, but I'm not asking for it on the test. Division is the same concept. So you can start by factoring with your division. Just make sure when you get to that second group that you flip him, all right? All right, so I'm going to look at this first group. He is going to actually stay the way he is other than I'm going to factor him, all right? So I'm going to look between the first two terms, and I'm going to say, well, I can take out a 5x squared. So I'm going to say 5x squared here, and I'm left with x minus 9. All right. In the denominator, I'm looking for factors of 18 that give me a positive 3. Negative 18 multiplied, positive 3 added. And so I'm going to get x plus 6, x minus 3. All right. That's my first keep. I'm going to keep that. I factor it, but I keep it. Then I'm going to change this division to multiplication. And this is going to flip, all right? In this case, he can't factor. If he could factor, I would factor him as well, right? But I'm going to flip it. So now my denominator that was x minus 3 is going to become my numerator at x minus 3. And my 1, which was the numerator, is going to become my denominator. And then I am going to see if I can cancel anything. So I'm going to look at the 5x squared. It does not cancel with anything. I'm going to look at the x minus 9. It does not cancel with anything. X plus 6 does not cancel with anything. But my x minus 3's will cancel. And so my final answer is going to be 5x squared, x minus 9, x plus 6 in the denominator. Nothing can reduce here. I am finished. So addition and subtraction, you're looking for a common denominator. That's how you do with all fractions, okay? If I could factor it, I would factor it. If I can't, I'm going to go straight to my terms and what they are. So I'm going to look at this first one. My common denominator will have to include an x plus 5. So I'm going to write down an x plus 5. My common denominator will have to include an x plus 4. So I'm going to include an x plus 4. All right. That is my common denominator. So I'm going to leave that as my common denominator. All right. Then I'm going to look at my first fraction. I have a 4 in the numerator. So I'm going to write down that 4. And I'm going to say, well, what do I need? The 4 already has the x plus 5. It needs the x plus 4. So that's what I'm going to multiply by. Make sure you put whatever sign is in between them. In this case, it is a plus. Then I'm going to look at my second fraction. 6x is my numerator. It already has the x plus 4. It needs the x plus 5. So that's what I'm going to multiply by. That is my setup. Now I'm literally just distributing and combining like terms, all right? So I'm going to distribute the 4 all the way through both pieces, 4 times x and 4 times 4. I'm going to put a plus, distribute the 6x all the way through, 6x times x, 6x times 5, all right? My denominator stays the same. You do not have to FOIL it. I do not require that. All right. In my numerator, I'm going to put it in standard form. I don't know that your answer key always does, but I always do, just so I know I don't forget anything. I go highest exponent, that's 6x squared. It cannot combine with anything. 4x and 30x, that's going to give me 34x, and then a 16. You can factor this if you want to. You can take a 2 out, and then you're going to get 3, 17, and 8. It will not factor and simplify, so you're welcome to leave it like that. If you could take something out and factor it and simplify it like we did on the first page, then you would do that here. Okay, so if you could factor it, then you would simplify it once you factor it, but it doesn't reduce. So you can leave it just like this. Subtraction is conceptually the same, just number one problem is people don't distribute the negative, all right? So we're going to get our common denominator just like we did on the other one. We have to use x plus 3, so we're going to use the x plus 3. We have to use 2x minus 1, so we're going to use 2x minus 1. And then from there, we're going to do exactly what we did before. We're going to look at our 4. The 4 already has the x plus 3. It needs the 2x minus 1. Make sure you bring down the subtraction sign now. Now we're going to look at our 3. Our 3 already has the 2x minus 1. It needs the x plus 3. And at this point, we're distributing. Distribute the 4 all the way through. 4 times 2x, 4 times negative 1. Here we are distributing a negative 3, okay? This is the number one mistake I see on these. Negative 3 times positive x is negative 3x. Negative 3 times positive 3 is negative 9. So number one problem I see here is people just do not combine those correctly because of that negative. My denominator stays the same. My numerator, I'm combining like terms. 8x minus 3x is 5x. Negative 4 minus 9 is negative 13. That is not factorable. So at this point, I am done. And that is my answer. So really from the addition forward, I'm always finding least common denominator. Like after you're done simplifying with multiplication and division, from that point forward, you need to be finding least common denominator, which is what we've been doing with addition. It's what we're going to do with complex fractions. It's what we're going to do with solving. So I basically look at all of my denominators, make sure they're in factored form. So like, for example, on this one, I would rewrite this 9 as 3 squared so that I don't have to reduce at the end. All right, I'm just rewriting him in factored form. So when I look at this to find a least common denominator, I have to use the u minus 3. I have a 3 squared and a 3 to the first power. Which one do I have to use? The 3 squared. All right. So my least common denominator is 9u minus 3. I don't have to say 27u minus 3. I'm not using my least common denominator at that point. I'm using a common denominator. But then I'm going to have much larger numbers, and I'm going to have to reduce at the end, all right? So does everybody see why I did that? All right? So now I can just multiply everything by 9u minus 3. So I'm going to multiply everything by my least common denominator of 9u minus 3. All right? And now I can do my canceling. So the whole u minus 3 cancels here, and I have just 9 times 9, all right? 9 times 9 is 81. That took care of that first piece. Then I'm going to put this minus. Here I have 9 and 9 cancel. So I'm left with the 2 and the u minus 3. That takes care of that one. My numerator is done as far as canceling goes. Let's look at the denominator. In the denominator, the 3 and the 9 will reduce. This cancels completely. This reduces to 3. So I have 4 times 3 times u minus 3. You cannot cancel anything right now. You cannot cancel the u minus 3's because there's a plus or minus. I'm just going to distribute and simplify. All right? So in the top, 81 I can't touch right now. I'm going to distribute a negative 2. Negative 2 times u. Negative 2 times negative 3. In the denominator, I'm going to distribute a 12, right? 4 times 3. So 12 times u. 12 times negative 3. One more piece of simplifying is combining like terms. I have 81 plus 6. That's 87 minus 2u. That is not factorable. In the denominator, I have 12u minus 36. That is factorable. I can take a 12 out and u minus 3. You're welcome to do that. It doesn't help you reduce, so I'll take it either way. So you're welcome to factor and see if it can reduce. I will take the factored form or this form. All right? So this is my answer right here. For this one, I'm going to, again, find my least common denominator. I have to use the x minus 5. It takes care of both of those. And I have to use an x squared, which takes care of those. So my least common denominator looks like that. I'm going to multiply every piece by that x squared, x minus 5. So I'm going to say x squared, x minus 5, x squared, x minus 5, x squared, x minus 5, and x squared, x minus 5. All right? I chose this one because it's going to look huge and you're going to want to try to cancel stuff. So this first group, the entire x minus 5 cancels. I'm left with the x squared times the 2x minus 3. Don't forget you have a minus right here, so minus. Here the x squareds cancel. I'm left with the 3 and the x minus 5. That's my numerator. In the denominator, the x minus 5's cancel here. I'm left with the x squared times the x squared. Here I have a plus. The x squareds cancel, and I'm left with 2x minus 3 and x minus 5. All right, you do want to FOIL this denominator just because you have two groups being added. So you do need to FOIL this guy to see if you can combine any like terms. So I'm going to distribute on the top. I have x squared times 2x. That's 2x cubed. X squared times negative 3. Negative 3 times x. And negative 3 times negative 5. All right, in the denominator, I'm going to combine these. X squared times x squared is x to the 4th. And then I'm going to FOIL this guy. So that's 2x times x is 2x cubed. I'm going to write this out to the side. 2x times negative 5 is negative 10x. And negative 3 times x is negative 3x. So that's going to be negative 13x. And then negative 3 times negative 5 is positive 15. All right, again, if you want to try to factor these, you can. It's not going to factor the numerator. Like you could try to factor by grouping. It's not going to factor by grouping. That's your answer. You can't cancel anything. You can't cancel anything individually. Just nothing's going to cancel here for you. So you're done at this point. That's all you can do with that guy. He's finished. So it is a big answer. Don't let it throw you if you have a big answer. It just means nothing reduces. So hopefully you see a theme here, least common denominator. I'm going to look at each piece of this. I have to have a 4. That takes care of all of that. If I had a 2 there, I would write it as 2 squared because I wanted to make sure I didn't double count it. 4. I have an a squared, an a to the first, and an a squared. What am I going to use? A squared. So I'm going to multiply everything by that 4a squared. All right. So I'm going to cancel what I can cancel. Here, the entire 4a squareds cancel. I'm left with just the 5. Don't forget you have a minus sign there. Here, the 4 and a will cancel, and I'm left with an a still and a 5. So I have 5 times a. Then put your equals. Here, the a squareds cancel, and I'm left with the 4 times the 2a minus 2. You'll notice I grouped that because we want to make sure that 4 goes all the way through. So when I'm simplifying, I am going to distribute that 4 over here. I have 5 minus 5a equals 8a minus 8. You want to put all your variables to one side, numbers to the other. So if I add the 5a to both sides, that's going to give me 13a. If I add the 8, then over to the other side, that gives me 13. Divide both sides by 13. A equals 1. Double check and make sure 1 doesn't cause a problem. 4 times 1 squared, 4 times 1, 1 squared. No problem. Those are all numbers I can have in a denominator. So this is my answer, a equals 1. So again, my goal is to find my least common denominator. In order to do that, I need to factor, okay? So I need to factor this, x plus 3, x plus 1. Factor this, x plus 3, x plus 1. And so now I'm going to look at this and I'm going to say, well, I need to use the x plus 3, but those are all to the first power. And I need to use the x plus 1. Those are also to the first power. So that is my least common denominator right there. X plus 3, x plus 1. And then I'm going to multiply everything by that common denominator. And now I'm ready to cancel. For this first term, everything in the denominator should cancel for everything. All of it canceled. I'm left with just the 1. Don't forget you have a minus sign right there. So I'm going to say minus. In this second group, the x plus 3 cancels, so I have a 1 times x plus 1. Don't forget you have an equal sign there. In this last group, all of it canceled. I have just the x minus 4 left. And I have a pretty basic equation to solve here. I have a 1. Distribute that negative 1 all the way through. Minus x minus 1 equals x minus 4. On this left-hand side, 1 minus 1 will cancel. So I have negative x equals x minus 4. Subtract the x over. What is negative x minus x? Negative 2x. What do you think my most common mistake I would see if someone did that problem? They would cancel the x's, right? So negative x minus x is negative 2x. Divide both sides by negative 2. Negative 4 divided by negative 2 is positive 2. Double check it. If I plug in a positive 2, this is going to give me 5. This is going to give me 3. 5, 5, 3. 2 does not cause a problem. The only way 2 would cause a problem is if one of my denominators was x minus 2, right? Then that would cause a problem. So that's my answer.